Okay, so we've seen all of this. So this is how we divide on like fractions. Now let's now see a pattern and see if we can generate a sequence from all of this. So give me the first fraction question. What's the first one? 3 out. No, I mean the first. This ones are whole numbers. I mean a fraction.
Okay.
3 out of
4 divided by 1 out of 4.
1 out of 4. 1 out of 4. I mean this question. Now the next one is what? 5 out of 10.
Divided by 1 out of 10.
Okay, third one.
5 out of 10 divided by 2 out of 10.
10. Fourth one.
3 out of 5 divided by 1 out of 2.
Okay, the fifth one.
4 out of 5 divided by 2 out of 3.
2 out of 3. 4 out of 5 divided by 2 out of 3. Now, we'll need. Any problem? Is there a sixth one? Where is it? No, I think this were like fractions. Yeah, so there's no problem. Yeah, good. Okay, no problem. So 1, 2, 3, 4, 5. Now let's try and see if we can get a pattern. Now, what I'll need from you to do is that you'd have to observe through and see if we can predict some logic around it. But the first thing to know is that when we're dividing 10 over 2, we also said that, fractions are also division problems. So division problems are also fractions. Agreed on that? Yes. So first preamble or first thing to take note of is that division problems, where do I get that? Let me get a little space here and put them at this side. So first thing, division problems can be written as fractions.
Yes.
Great. So that would mean I can write this. If that's the case, if I have 10 over 2, I can write it as 10 divided by, or I can write this as what? 10 all over 2. Is that okay?
Yes.
It makes this one the numerator and this one the denominator. Is that okay?
Yes.
So when I have 3 over 4 divided by 1 over 4, what am I going to see as the numerator?
4.
No. What if I have 3 over 4 divided by 1 out of 4? Which among these two is going to be the numerator? 3. The whole of this. The whole of this is going to be seen as what? The numerator. Look at this. The whole of this is seen as the numerator. And the whole of this is seen as the denominator. Do you get that?
Yes.
So this whole thing is going to be seen as the numerator, and everything here is going to be seen as the denominator. So I can write it this way. I can write it as 3 over 4 all over 1 out of 4. Do you get that?
Yes.
All right. So 3 over 4 all out of. I just wrote this thing in a different form. 3 out of 4 is seen as the numerator, and then 1 out of 4 is seen as the denominator. Let's say I can replace all of this with a divided by b. So a fraction is seen as just a numerator. Okay, so we have 3 out of 4 all over 1 out of 4. Now, my first question is that I really want to manipulate this such that my question does not look so bulky. Because this is looking like there's something up. I don't want to have it like that. I want to have it as just one stretch of fraction in my, like what I've been doing all the while. So I would like to change this denominator into 1. But what can I multiply with this 1 over 4 to make it to be 1? What do you think? Yeah?
So you flip it.
Exactly. Okay, so we now have something like this. Times 4 over 1. So eventually I'm going to get something, but then one rule, just when I do this, I'm going to arrive at the 1, because 1 over 4 times 4 over 1. What's 1 times 4? What's 4 times 1? 4. I'm going to finally arrive at 1. So I'm going to successfully get my denominator to be 1, right?
Yes.
But then one rule is binding me. Just when I do this here, I'm supposed to do the same thing over here as well. Can you see that?
Yes.
So I'll now multiply this one with what? 4 over
1.
exactly 4 over 1. So my question is now going to look like this equals, as I've successfully gotten this 1 to be 1.
Yes.
And anything divided by 1 is itself. Can you see that?
Yes.
So I will now have 3 out of 4 divided by, multiplied by 4 out of 1. Is that okay?
Yes.
Now let's try something. So what's 3 times 4? 12. 4 times 1? 4. So what's 12 divided by 4? It's 3. Now let's see if, look at this answer here. And where's the answer on the board? Look at this same one here. Can you see the relation?
Yes.
So we've been able to do this just by using these diagrams. And then we've been able to use a certain math concept to get the same thing. Now let's try and see if we can predict all the others just following this rule. Now we can all see that. So this, how do we write this particular question now? Which of these two fractions is going to be the numerator?
5 out of 10.
Yes, 5 out of 10. So I'll have 5 out of 10 all over what? 1 out of 10. Perfect. Now, how do I make this guy to be 1? You flip, and I'm going to multiply by 10 out of 1. But whatever I do down here, I must do the same thing upstairs. Right? 10 out of 1. So I've succeeded in changing this whole thing to get me 1. Because if I should do it here, so 1 times 10 over 10 times 1. I'm going to get 10 over 10 is equal to what? 1. These are whole fractions. And all whole fractions are equal to 1. Clear on that?
Yes, sir.
Alright, so we now have, if you watch carefully, you see how beautiful the pattern is. 5 out of 10. Okay, we would have color coded well. 5 out of 10 times what? 10 out of 1. And I'm going to get what? 50 out of equal to, no, 50 out of 10 equals to 5. Can we locate this somewhere? Here. Can you see that?
Yes.
So let's try the third one. So
I just found something that when the 10 over 1,
okay.
or at the other board over there,
Mm-hmm.
is the less
Exactly. So you have seen quickly that it looks like we are just, so let's even with this two, we can just trace that. It looks like whenever you are giving a question, so I think she got it. If you are giving a question, you just have to flip. The pattern is that this guy keeps changing. Or what do you think is happening to this first guy?
It keeps itself.
It keeps itself, right?
Yes.
It keeps itself. So first one, so it keeps itself. Then what's happening to the division?
It changes.
It changes, right? Or it changes to what?
Multiplication.
So it keeps itself, changes. And then what happens to the third one?
It flips.
It flips. So it means that when you are given any question, so you just have to keep the first one, change the second one, and then flip it. So after a lot of rough work with mathematicians, decided that just how you guys also just found it out, that if you are given the work, just make sure you keep the first one, change the sign, and then flip. So can we do that very fast now?
Yes.
So what do I keep?
Keep 5 out of 10.
5 out of 10. Change the sign to multiplication. And then flip This
10 out of
10 out of 2. I would have 5 times 10. 5 times 10. 50. 10 times 2. 20. What do I have? That will be what? 5 over. How many times does, sorry. How many times does 20 go into 50?
2 times.
2 times. Remember, 10 out of 20. In other words, is equal to 2 whole number. 1 out of 2. Do we have it somewhere?
Yes.
Do we have it somewhere?
Yes.
Fantastic. So it's here. And then it's here as well. Can you see that?
Wow.
Alright, so it's okay. Now let's trace this one too. Alright, so let's do that fast. So 3 out of 5. Divine, I like how you are very quiet. Yeah. Times flip this guy, right?
Yes.
2 out of 1. It's equal to 6 out of 5. An improper fraction. So that will be, how many times that's 5 going to 6? 1 remainder. 1 out of 5. Is it somewhere on the board?
Right down there.
Where?
Yeah.
Here?
Yes.
Oh, good. Wow, beautiful. Next one, we have 4 over 5 times 3 over 2. That would be equal to 12 out of 10. How many times does 10 go into 12?
Once.
So once remainder 2 out of 10. So do we get the same thing?
Yes.
Great job. So this is how we manage to arrive at, it's okay, at keep, change, flip. So after making this, so now let's get a name for this. Keep ketchup. Can I say ketchup? Ketchup covers fries. So that's how to keep it. It's a good mnemonic. Ketchup, you know ketchup?
Yes.
The red thing you pour on. Oh man. Please, I don't like the case here because you like going to confuse this and go and do KFC. Not KFC, because if you do KFC, I'm going to keep flip and change. That's going to be a lot of catastrophe there. So ketchup covers fries. So after the ketchup has covered the fries, you keep chewing the fries. Keep chewing fries. So keep chewing fries. Ketchup covers fries. So when you have to do division of fraction, just keep this in your mind.
Ketchup covers
Fries. That's it.